Our second part of this question says we've got to use the very same sequence, but now look at the way they ask the question. Let's read the question. If this series, now the series is the same, but this time they give us a value. Now remember, we'll talk about that just now. They want us to find the value of P. So in other words, where is P? Well, P is here at the bottom of sigma. P is where we are going to start counting the terms in this sequence. That starts at P. Now remember, we said that if we have our sigma, we have the general term given. Well, here we have n equal from 1 to infinity. So in general, this gives us the number of terms in this series that we're going to add. Now that is equal to the sum of the series. So what did they give us? They gave us the sum, and over here they gave us the general term. And the number of terms is what remains unknown. Now remember, we knew that this was a sum to infinity. We knew that right from the beginning. And we now need to know how many of those terms will add up to a sum of 2 over 9. Okay, so that ain't that difficult. Well, let's write down what we know. We know that the term k, in other words, the general term, is 4 times 3 to the 2 minus k. And in this case, the value of k is p. So our very first term, for term 1, we're going to let k equal p. So what do we know? We know that term 1 is usually a, so a will be 4 multiplied by 3 to the 2 minus p. Okay, that is what we know. We also know from our previous calculation that the sum, or the constant ratio rather, is a third. Then we've also learned our sum to infinity is equal to a over 1 minus r. We know that as a fact. Okay, so now we want to know how many terms with these characteristics here do we have to add together to get a sum of 2 over 9. So our sum is 2 over 9. Our a value is 4 multiplied by 3 to the power 2 minus p over 1 minus a third. Now, folks, that looks ugly. I don't like fractions. So what I usually do is I multiply by the LCD of the denominator within the fraction, which is 3, this thing here. So I multiply by 3 over 3, and I'm doing nothing else but multiplying with 1. Put it in your tips. 3 over 3 is 1. Why do I do that? I'm getting rid of my complex fraction. Now remember, a complex fraction is a fraction on top of a fraction. So if I multiply that, I get 4 multiplied by 3. Now if I add like bases, I add their powers. If I multiply them, I add their powers. 3 minus p. In the denominator, I get 3 minus 1. 3 times 1 is 3, and 3 times 1 over 3 is 3, so I have 2 over p. Now I've got a fraction. Now remember, I'll put this for you in your sketchboard, that if you have a over b, which is equal to c over d, you can say immediately that a times d is b times c. Okay, so let's do that. 2, 3 minus 1 is indeed 2, and 2 times 2 is 4, which is equal to 9 times 3 is 36, multiplied by 3. 3 minus p is still in the power. Okay, now it's a case of getting those bases the same. Remember, go to your sketchboard. If we have a to the m, which is equal to a to the n, then we can ignore these bases and work with the powers. We're not cancelling them, we are ignoring them. So we're going to try and get that done as soon as possible. Now let us have a look if we can create another 3. I don't want to touch this part over here. That already has a power of 3 minus p connected to a base of 3. So I'm going to say, let me take 4 and divide 36 into 4. Now that gives me 3 to the power 3 minus p. 4 goes in there 9 times. We get 3 to the 3 minus p, simply just 3 to the minus 2, which becomes 3 to the 3 minus p. So I just took that up. Remember your rule, your exponential rule, 1 over a to the m is the same as a to the minus m. And that's what we did here. We now have our two bases the same, folks. So what can we say? We can immediately say that minus 2 is equal to 3 minus p. The 3 comes to the left. I have minus 5 is equal to minus p. And it's clear to see that p is indeed 5. Now, folks, this was for 5 marks. You had to do a little bit of work here. Okay, so it's not that difficult to do this. You just have to be very careful. Use what you know. Use it very, very intelligently. Okay, to go back to another sum here would have been a little bit too much. But I just want to show you how much you needed to know. You needed to know your infinite series formula. You needed to know the general formula of a term that's geometric. You needed to know basic fractional equations. You needed to know exponential rules that helped you to solve this problem. Most of all, you needed to know how to get rid of that complex fraction. There's a lot of mathematics below the surface here, folks. Know your work. You can do well. This whole question 3, was for a total of 8 marks. Should not take you more than 8 minutes.